Good day, everyone. You are welcome to my YouTube channel. This wonderful day, we are going to be looking at bearing and distance. How do we solve questions when we see questions on bearing and distance? We are going to be seeing an example on the board. So let's see how we tackle this question. Now, the question reads that a boat sails 150 kilometers on a bearing of 042 degree and then 250 kilometers due east. How far is the boat from the starting point? Now, we'll start by interpreting the question one after the other. Let's look at the beginning of the question. It says the boat sails 150 kilometers on a bearing of 042 degree. Now, this kind of a bearing is what we call a three-figure bearing. And when we are having a three-figure bearing, we always start to measure the bearing from the north. So we are going to be measuring this 042 degree from the north. Now, when we measure this 042 degree from the north, we are going to be moving this distance. So if this is the starting point here, a boat now sails 150 kilometers. We don't know, maybe towards here or towards here or towards this direction, but the bearing will tell us the direction that we are going. Now, we say we are measuring that bearing from the north. This is our four cardinal points: north, south, east, and west. Now, the boat is at this place. That is the starting point. So the boat wants to sail 042. So it was facing like this. It turned 042 degree. 42 degree will not be up to half of this side, but almost half. So the boat is now facing towards this direction here like this. This is our 042 degree. The boat was here and it was facing towards this side. It now turned 42 degree like that and moved like this. And when the boat moves a total of 150 kilometers. Now the question now went further to say, and then that means the boat is here now. The boat left here and go to this place. That is why you see this, and then 250 kilometer due east. Now this is where the boat is. The boat is moving due east. This is our north. This is our east. So the boat is moving towards this direction now. The boat is moving like this, due east, but the boat is moving 250 kilometer due east. Now we have to make sure that our 250 is longer than our 150. I cannot just draw here and stop here. If you look at it, this one is a little bit shorter than this. So I have to extend it so that it will look as if it's real. So when I extend it, it's going like this. So let me just say this is my 250 kilometer. This is where the boat is now. The question now says, how far is the boat from the starting point? This is the boat, this is the starting point. So we are looking for distance from here to here. I'll now join it together to give us a triangle. Now that reminds us that any drawing that we are going to be having on bearing, you always get a triangle that you can easily solve to get your answer. Either you are looking for the distance or you are looking for the bearing. Now in this case, we are looking for how far is the boat from the starting point. We are looking for the distance from the starting point to where the boat is. Let's call that x. Now here, you needed to know at least one angle inside any triangle that you are given before you can look for the distance. Here, if here is a 42 degree, that shows this small angle here too is also 42 degree because that is alternate angles. This angle is alternate to this angle because anytime you see two straight lines drawn like this and you draw a transversal that will cut the two straight lines, the angle here is alternate to the angle here. And that is exactly what we are having. These are the two straight lines, north and south. So we have this transversal that is cutting it. This angle is equal to this angle. While this angle, this other angle here inside the triangle is 90 degrees. So for us to get the total angle at this point, we needed to add the 42 degree and the 90 degree together. So we add the two of them together. we are going to be having 132 degrees. With this angle now, we can easily calculate the distance of the boat from the starting point. So it's either you use sine rule or cosine rule. I believe we are all familiar with sine rules and cosine rule right now. Now, in this case, we are going to be using the cosine rule. Anytime you are looking for opposite side and you are given the two other sides and the included angle, the angle must be in between the two other sides that you are looking for. With this now, you'll be able to look the opposite side of this angle, able to look for it. Now, the cosine rule we apply is s squared equals to y squared plus z squared minus 2yz cos x. Now, if we apply this, we are going to be having, this is our x, y, and z. The small s facing the big S is our small x, while the big Y, the side facing it is our small y, while the capital Z, the side that is facing it is our small z. Now with this, now we can substitute into this cosine rule. So if we substitute here, our S is unknown, our Y is 250 squared plus our Z, this our Z is 150 squared minus 2, then Y 250 times Z 150 cos our capital X, which is 132 degrees. So if you solve this, you'll be having, now if you want to solve this, what you needed to do is to solve both sides differently. You look for the square of 250, you add it to the square of 150, you leave it, then minus, you multiply this by this times this, 2 times 250 times 150. You now times it with the cos of 132. You look for cos 132, you multiply everything here together. Here, you are going to be having a negative answer from the cos of 132 because it enters the second quadrant. So when you have the minus here, you now times it with this. This will now change to plus. So the answer you get here, you now add it to the answer you get on the other side. So when you sum the two together, your final answer that you should be having here is 368 kilometers. So you can try that at home. If you're able to do that, tell me if you're able to get 368 kilometers. If you are not, feel free in my comment section, comment, like, and subscribe to my YouTube channel. I'll see you in my next video. Thank you.